students, I am Nilima Salvi, working as Assistant Professor in Department of Pharmaceutics, Smriti College of Pharmaceutical Education, Indore. In Physical Pharmacy 1, today we are going to start with the unit number 3rd, that is Interfacial Phenomena. So, in interfacial phenomena, what happens? First of all, we have to understand the word interface. That what is the meaning of interface? So what is interface? Interface, actually it is a boundary in between two phases. What are phases? So in previous unit you had learned regarding the phases, that is solid, liquid and gas. There are three phases: solid, liquid and gas. So interphases, it means the boundary in between any two of the phases. It means interface. For example, suppose if we have a solid substance, this is a solid substance, and environment is gaseous. So this is gas and this is solid. So in between this two phase, the boundary which get exists, that is known as interface. But if from these two phases any one of the phase is gas, अगर दो फेज में से कोई एक फेज गैस होता है तब then it is known as surface. So surface, if one of the phase is gas, then the interface is known as surface. So this is first example of the surface. This is a solid material and environment is gaseous. So the interface would not exist. On place of that, a surface would appear of that solid. For example, if I have this pen, so this is a solid content and the around the gas which is present. So these are the two phases, solid and gas. So actually the interface doesn't exist and interface known as the surface. So this is the surface. So this was first example of interface. Then second is suppose if this is a liquid and this is gas. So again the interface which will exist in between the gas and liquid, it would be actually the surface of liquid. So this was example of liquid and gas interface, solid gas interface, and this is another example in which one solid substance is there into liquid and this is gaseous environment. So the interface in this case would be solid liquid interface. The place at which solid and liquid get contact or boundary in between solid and liquid, it is known as solid liquid interface. And suppose again if we talk about the liquid and gas, so in this liquid and gas, now the surface of liquid would be act as a interface. So this was solid gas, solid liquid and liquid gas. And another example is liquid interface. Suppose if we have two immiscible liquid which doesn't get miscible with each other. So in that case, suppose if this is this water and this is octanol. So in octanol and water, one interface would exist or boundary would get exist where the two phases get separate. So this would be liquid interface. So this was all about the interface, that what is the meaning of interface and surface. So in this unit we have to deal about the interfacial phenomena. It means the phenomena or the fundamental properties or behavior which exist or work onto the interface. So first of all we had learned about the interface, that what is the interface. After that, interface and surface. There is no interface observed in between the two gases. We talked about the solid gas, liquid gas, solid liquid, liquid gas, liquid liquid. Now if we will talk about the gas, so all the gases are miscible with each other in all the proportions. That's why there would be no interface would exist in between the two gases. It means that कि सारी गैसेस जो होती हैं दे आर मिसिबल, वो एक दूसरे से मिसिबल होती है. दैट्स व्हाई इन बिटवीन टू गैसेस देयर वुड नॉट बी एनी इंटरफेस वुड एग्जिस्ट. यहाँ कोई इंटरफेस एग्जिस्ट नहीं करेगा क्योंकि दो गैस आपस में मिसिबल होती हैं. ठीक है. सो दिस वाज दैट नो इंटरफेस observed between the two gases. Then in prevailing the environmental condition, it circumstances like temperature and pressure. When the temperature and pressure affect this different situations of phases, then the molecule which would be present at interface would behave differently rather than it would present into the bulk. It means what कि अगर कोई मॉलिक्यूल है तो मॉलिक्यूल अगर बल्क में प्रेजेंट है और सरफेस पर इंटरफेस पर अगर कोई मॉलिक्यूल प्रेजेंट है तो इंटरफेस पे मॉलिक्यूल अलग बिहेव करेगा रादर देन कि वो बल्क में क्या बिहेव करेगा. इट मीन्स व्हाट, सपोज देयर इज अ molecule. If this molecule is in bulk, so this will behave differently, and if this molecule as the interface, then this would behave differently. So this would be depend on to the condition, that is temperature and pressure. After that, the solid interaction is very much important in pharmacy. Why so? Because of the addition of granule to form the tablets. It means जो solid interaction होगा, so because of that solid interaction we will form the granule or we make them adhere with each other, so we will form granules for the tablet formulation. And through this solid interaction again we will find the flow characteristic of granule, or we will make the granule flowable from the hopper. So this was the solid interaction. Now what is granule or how we use this granule? So in tablet formulation, first of all when we add or mix all the raw material to combine them as a damp mass, after that mass we convert the mass into the granules. So after that we compress these granules as a tablet. So to make the granule we have to study about the solid interaction, and this solid interaction is much more useful in pharmacy. After this introduction about the interface and surface, so start with the applications of interfacial phenomena. It means how the interfacial phenomena would be useful for us. So first of all, this interfacial phenomena would be useful for the fundamental principle of interface mainly determines manufacture of dosage form. That which dosage form we have to prepare, we will select the dosage form. After that, the performance or result of that dosage form onto the basis or behavior of the interfacial phenomena. Then interfacial tension, we have to study about the interfacial tension of the content to the content into the vehicle. After that, adsorption property. Adsorption, it means how much amount which can adhere onto the surface of solid particle. Sometimes the material would not adhere onto the surface of solid particle. In that cases, we have to add wetting agent to make this surface wettable. After that, disintegration and absorption of drug. Again, this disintegration and absorption of drug would be affected because of the interfacial properties of the solid substance into the formulation. Then spreading of the ointment, again this is the result because of the interfacial energy of the compounds. Then selection of surface active agent into the formulation like suspension and emulsion. So in that case we will select the surface active agent with the interfacial phenomena or interfacial behavior of the immiscible liquids. Then certain physicochemical properties such as zeta potential, contact angle, etc. So these properties we have to determine for the dosage form or for the evaluation of the dosage form. So these properties again we can obtain because of the interfacial phenomena. So this was the introduction of interfacial phenomena and applications. In next video we will start with the surface tension and interfacial tension. Thank you.